So these are some quick notes over radical notation. There's a bunch of examples in this. So if it looks like these notes are long, if you look at the video or how long the video is, it's because there's a bunch of different examples. So I'm going to go through the first couple examples slowly, but then I might start picking up the pace. So the objective, students to be able to rewrite problems that are in exponent form and radical form and vice versa. So we're really just switching between radical form and exponent form. So these are some examples that are not in your notes. So the big thing is this this equal, where if you have a fraction as an exponent, your numerator is going to be your exponent. Your denominator you can change into your index number. Now the other way you can write this is you could put the exponent out front. Most of the time I write it this way, but sometimes it does help a little bit to write it the other way. So x raised to the 2/3, if we put that in a radical form, so this is exponent form because we have it as an exponent. As a radical form, the denominator goes up front, and then we have x squared. Again, you could do it this way, but that's a little bit easier to write. Same thing with this one. We have the radical 8 t to the 5th. Now they act like there's a special rule for these where there's 1/4, and really it's the same thing we've been doing. So this is the 4th root of x to the 1st. Well, x to the 1st is x, so this is just the 4th root of x. This one is the 7th root of m to the 1st, so it's just the 7th root of m. Now the little shortcut they give you, and again, I choose to not write it down because it's the same as what we've been doing on the other ones. But the shortcut is if it's 1 in the numerator, 1/4 is just the 4th root or the 7th root. So the working backwards, I guess I should say. Okay, the 3rd root of 27. If you don't know how to put this in your calculator, you could have done 27 raised to the 1/3 power. So you can go vice versa either way. You can go from exponent to radical or radical to exponent. So this is that special way where if there's a 1 in the numerator, you can just do the nth root. I don't do that because it's literally the exact same as this, and I'd rather not show you guys two equations and make you guys confused. So again, I'm going to try to go slowly through the first one, but it should go pretty quickly. So this is the 8th root of a to the 1st, which is just the 8th root of a. The 3rd root of n to the 1st, which is the 3rd root of n. Down here, now we just have a number. Just FYI, this a is the base number, n is the base number. So now we have a number for our base number. We have the 4th root of 5th to the 1st, the 3rd root of 7 to the 1st. Now these other ones are a little bit tricky because this is the 3rd root of 8, but we can reduce that down. The 3rd root of 8 is actually 2. So if you can ever reduce one of those radicals, please do so. If you forget, it's not the end of the world, but you're always going to want to check that. Most of them are pretty easy or pretty straightforward, or ones that we recognize. That said, I don't know if a lot of you guys knew the 3rd root of 8 was 2, so maybe they are a little bit sneaky. But like this one ends up being the square root of 25. Hopefully you guys know that that's 5. If not, if you leave it like this, you'll still get most of your credit, just not all your credit. So go ahead, do these on your own, hit pause, watch these, do these on your own, and then hit play so we can check your work. So this one ends up being the 5th root of v, the 4th root of 6. Again, see if you can simplify that out. And the 4th root of 81. If you look to see if you can simplify that out, it ends up being 3. I think the thing with this, I'm trying to remember because it's been a while since I've done this. Most of the ones that are this way, if you can reduce it, it's a nice whole number. You don't have anything that's like, oh, it's 44 times the 4th root of 6 or anything like that. I think this type, if you can reduce it, it's a nice whole number. So now we're doing this opposite. We're writing in simplest radical form. Now the big thing with this is you have to remember that an exponent raised to another exponent means we multiply. So we have 3, which is 3 over 1, multiplied by 1 over 6. When you do that, you multiply the numerators and multiply the denominators, then simplify if you can. So this is the same thing as x to the 3 over 6. And if we simplify that, that is x to the 1 over 2, sorry, 1 over 2. Now realize it says simplest radical form. So this is an exponent form, so the last step, make sure you put it in radical form. So this one, 1 times 2 is 2. 6 times 1 is 6, so that's n to the 1 over 3, which is the third root of n to the first. Again, hit pause real quick, do this one on your own, and then hit play so we can see the answer to this. W5 over 20, which is w raised to the 1/4, which is the fourth root of w. Again, technically the fourth root of w to the first power, but you don't really have to put the exponent in that. So these are a little bit easier because we don't have to multiply. So this is just the third root of 5 squared. So I would say the third root of 25. I do want you to go ahead and do that. Since we know what 5 squared is, go ahead and put that in there, or you can put it in your calculator and see. But you can leave it as a radical because it is a radical notation. So this one, the fifth root of 3 to the third. Put 3 to the third in your calculator. That's the fifth root of 27. And the last one is the seventh root of 2 to the third. So that is the seventh root of 8. So again, this is what I'm talking about, where it's not that hard. It doesn't take that long, but you have to make sure you're being careful because it's very, very easy to switch some of these around. It's really easy to say for this one that it is the third root of 3 to the fifth or something like that. So it's very easy to get those two mixed around. So make sure you're doing practice. We're going to skip A, B, and C. That should say C. We'll get back to it in a second. So now we want these in simplified exponent form. So they're in radical form. We want them as exponents. So we're just working backwards. So it might help if there is no exponent. It might help to put a 1 there. So this is m raised to the 1/7 exponent. The exponent goes on top. The index number goes on bottom. P raised to the 1/3. Again, number 7 is a you-do, so pause it for a second and then come back, check your answer. Shouldn't take long. Now this one's a little interesting because if it doesn't have an exponent, you want to put a 1. If there's no index number, remember it's a 2. So this is the same thing as a raised to the 1/2. So now going back to 6A, B, and C. I don't know why they did it in that order, and I don't know why I haven't changed it yet, but I have it. So the first thing I would do to get these in simplified radical form, it seems backwards, but I would change the radicals into exponents. So the square root of 7 to the 4th, well, this one is 7 to the 1/2 to the 1/4. Now we can multiply our exponents, so we have 7 to the 1 over 8. And now we can switch that back to radical form. That's the 8th root of 7. I think that's the easiest way to do this. There's other ways to do this, but I think that's the easiest. And I know it seems like you're taking one step forward and then one step right back to where you started, but I do think that's the easiest way. So same thing, this one is 5 raised to the 1/3, raised to the 1/2. So that's 5 raised to the 1 over 6. Switching it back to radical form, that's the 6th root of 5 to the first. Go ahead and do this one on your own. So hit pause. That's 3 to the 1/2 raised to the 1/5. That's 3 to the 1/10, which is the 10th root of 3. So now this one is back to exponent form, one exponent form. So I think these are actually easier than the ones we just did. You just have to make sure this is n raised to the 2 over 5. X raised to the 4 over 7. Just make sure the exponent's in the numerator. And x raised to the 3 over 4. Again, it's not that hard, but a lot of people have those flip-flops. And so they miss every problem like this because they don't have the right numerator and denominator. The exponent is always the numerator. The index is always the denominator. So now this is what we just did with number 6, except for now it's nicer because we can leave it in exponent notation. So we have 4 to the 1/3 squared. So that's 4. This 1/3 doesn't look very good. That's 4 raised to the 2/3, and then again we just leave it like that. It says simplified exponent notation. So this is 7 to the 1/5, and actually, funny I didn't even think about that. 7 to the 1/5 raised to the 3rd, so that's 7 to the 3/5. The thing that I just remembered is at the very beginning of this, remember we said you could also write it this way. Well, that's what we have on all these problems. So really, I'm doing it the longer way. Because you could just say, oh, well, that exponent's outside, so this is 4 raised to the 2/7. So really, again, I'm doing it a little bit of a longer way because that's not the notation that I usually use. Either way is fine. So for this one, I would have started with 4 to the 1/7 raised to the 2nd, and then went to that 2/7. Let's see, so in exponent notation again for this one. So I have a 2 here, so that's 3 raised to the 8/2. The big thing with this is make sure you reduce. 2 raised to the 6/3, which is 2 raised to the 2nd, which actually, 2 raised to the 2nd is 4. We should go ahead and do that one because that's an easy one to put in your calculator. 3 raised to the 4th, should have been paying more attention, is 81. That one's not bad. The last one is 5 raised to the 8/2. That's 5 to the 4th. Put that in your calculator. It is 625. All right, so these other ones simply just say simplify. So we'll see what we can do with this one. So the first thing, anytime it says simplify, the first thing I would do is put it into radical notation. So this is the square root of 144 to the 3rd. Now, I will give you a hint with this one. I haven't done it this whole time, but it's easier to take the radical first before you take the exponent. So you can do it both ways. I'll show you both ways. If we do the radical first, the square root of 144 is 12, so it's 12 to the 3rd power. 12 raised to the 3rd power is 1728. Not too bad. If you do it the other way, where you take the 3rd power first, it's the square root of 144 raised to the 3rd power. It's the square root of 2985984. And if you take the square root of that answer, you end up going right back to this answer. So it doesn't make much difference. This one is a lot longer of a problem, but you're going to do it in your calculator anyway, so it doesn't make much difference. This one is 32. It's the 5th root of 32 squared. So again, check to see if the radical can be reduced first. And a lot of these, especially to the 5th root, you can use a calculator, but you can also use your chart for some of these. The 5th root of 32, I think, is 2. Yeah, so this one ends up being 2 squared, which is 4. Again, you could have squared 32 first and then taken the 5th root. It doesn't make any difference. The 4th root of 81 to the 3rd. The 4th root of 81, again, if you look on your list, it should be on there, is 3. So 3 to the 3rd, which is 27, which is also on our list. So they try to make it more difficult with these types of problems, but again, don't make it hard. We just multiply our exponents first. So this is the same thing as 4 raised to the 15/3. So it's the 3rd root of 4 to the 15th. I'm thinking on a test or quiz, it'll be more specific on if you should leave it in radical notation or exponent notation. This one doesn't really say, but this one's going to end up being a decimal, I believe, because there is no 3rd root of 4. So if you do this as a decimal, which you should not, so I would not recommend this, but that's 4 raised to the 15. that answer raised to the, or sorry, the third root of that answer. Oh, maybe it does work out. Huh. All right, well, egg on my face. I was wrong, so it's a good thing we checked this. So this one, if you do the third root of 4 first, you get some decimal, but then when you raise it to the 15, it totally works out. Oh man, I'm ashamed of myself. So here's the problem with this. And this is what happens. This is a perfect example. I'm trying to go quickly because I want to make sure you guys don't have like an hour-long video, and you're going to miss some of these small things. 15 divided by 3 is just 5. So 4 to the 5th, it's just 1,024. That should have been an easy one. So always check to make sure you reduce your fractions. And as you can see, if you go too quickly, sometimes you make that mistake. So this is 6 raised to the 6 over 2, which is 6 to the third. Use your calculator or your exponent sheet. That ends up being 216. This one is 7 to the 4 over 4, which is 7 to the first, which is just 7. So definitely check to see if you can reduce those fractions. I'm glad I double-checked my work. That's another good lesson. Double-check that stuff. So this is what we also did earlier, where we started by putting it as an exponent first. Reduce that exponent. We learned our lesson. That ends up being 81. This is 10 raised to the 1/5, raised to the 20th. So that's 10 raised to the 20 over 5. So that's 10 to the 4th. That should be 10,000. And this last one, again, doesn't have an index number, so make sure you put a 2 with it. So that ends up being 11 to the 1/2 raised to the 8. So that's 11 raised to the 8 over 2. That's 11 to the 4th. That ends up being 14641. So this is where it's getting a little bit more difficult. You have to remember, if you have a multiplication problem to an exponent, that exponent goes to both of these. So what a lot of people forget about is if you have like 3 times 2x, this is just 6x. You don't take the 3 times the 2 and the 3 times the x. That's not how you do it when you multiply. But when you have an exponent, that exponent has to go to both of those. So that's 729 raised to the 1/6 times a to the 18 raised to the 1/6. The 729, we'll kind of do this separately. If you set it up as a radical, it might be a little bit easier, and you can use your chart. Ends up being 3. And personally, I just put this one in my calculator. This next part, we have a to the 18 over 6, which is a to the third. So that's your answer then, 3a to the third. Again, same thing here. 331 raised to the 1/3. B to the 12th raised to the 1/3. That's the third root of 1331. And if you skip that step and just do it in your calculator, I'm totally fine with that. That is 11. And then this ends up being b to the 12 over 3, which is b to the 4th. So 11, b to the 4th. 1/4, b to the 20th, to the 1/4. So this is the 4th root of 1296. It's 6, and then this is c to the 20 over 4, which is c to the 5th. So 6, c to the 5th. I think these are about the last ones. All right. So keep on doing this. We have 36 raised to the 3 over 2, and x to the 6 raised to the 3 over 2. As you can imagine, this is going to be where it gets a little bit, oh, you can see, the square root of 36 to the 3rd. Again, I would take the square root first. So that's 6 raised to the 3rd is 216. Now here's the thing with this that I'll tell you. I would just put this part in my calculator. Just use your fraction button, 36, exponent, 3 over 2, enter. That skips a lot of this work. So that's what I would do. Then this one ends up being x raised to the 18 over 2, which is x to the 9th. 16807 raised to the 2 over 5, y to the 10th, raised to the 2 over 5. So technically, that's the 5th root of 16807 squared. So again, I would take the 5th root first. Is 7. So 7 squared is 49. But again, I would put this part in my calculator if I were you. And then over here we get y to the 20 over 5, which is y to the 4. And again, you're just multiplying those. I should have wrote them a little closer together. So now we have the 4th root of 6561 to the 3rd. I guess I kind of skipped a step there, but that's okay. Z to the 8th, 3 over 4. So 6561 raised to the, or sorry, the 4th root of that, or raised to the 1/4 is what I did. But again, I would always just put that fraction in my calculator. I think that's way easier. That's 729, and then we have z raised to the 24 over 4, which is z raised to 6. So I know at the end I was kind of going a little bit quickly through that, but again, there's a lot of the stuff, a lot of shortcuts you can use with your calculator. Like I said, I know I'm a broken record, but I would have put this in my calculator right away, and I would have skipped this whole step. This I would have put in my calculator, I would have skipped this whole step. So I'm okay with that. You can do that. If you don't know how to put those in your calculator, let me know, and I can definitely show you how.